Brandon Scott is an immersive technology applications engineer at the Johns Hopkins Applied Physics Lab. He has worked on a variety of XR projects ranging from emergency care training, human-machine collaboration, biometrics, and XR collaboration. He has extensive expertise in Unity, 3D animation, and user experience design. And for Hannah Cowley is an associate research scientist in the neuroscience group and acting section supervisor of the neurological health and human performance section at APL. Her research centers on combining statistical and machine learning techniques with non-invasive biomarkers to quantify mental illness risks and symptoms. She is broadly interested in using quantitative tools to tackle problems of public health importance, from mental health promotion to interactions between climate change and human health. Hannah earned her Master's of Public Health from the Johns Hopkins Bloomberg School of Public Health this past May, and her Bachelor's in Cognitive Science from Johns Hopkins in 2018. Please welcome Brandon and Hannah.
Thank you. That was a great introduction. Really appreciate it. Like you said, my name's Hannah Cowley.
And I'm Brandon. Oh, a little loud.
And now you can all hear us. And we're presenting on AARDVARK, which is this very, very cute little animal using a VR headset because graphics make everything a little bit cuter. And we're really focused on inventing the future of neurological testing by assessing attention-related deficits using VR. So to motivate our problem, I want to walk you through how attention deficit disorder, or attention deficit hyperactivity disorder, ADHD, is diagnosed currently. And we're going to use this case study of a kid and their parents, let's say, because this is what we tend to think of when we think of ADHD. Although please note, we are trying to make a system that looks at attention deficits broadly, not just for ADHD. But getting to it, the way that you would actually diagnose ADHD, let's say you're having problems with a child, you're the parent, you bring them to the doctor. A lot of times this is your family physician, not usually someone who's specialized. It can be a psychiatrist, can be a psychologist, but mostly the pediatrician. And they'll run down a set of sometimes some standardized questions, also their very, very great training, their clinical intuition, and ask questions like, how's the child doing in school? They might ask questions directly to the teacher as well. Again, sometimes they're standardized forms, sometimes it's a little bit just an email or a phone call. And they'll also ask parents, how's the child doing at home? This is important because in order for someone to be diagnosed with ADHD, you have to show the symptoms across a bunch of different environments. They'll combine all that information together and use, again, their clinical intuition, but some very complicated flow diagrams like this one from the American Academy of Pediatrics to say, does this person have ADHD and should I treat them? It's important to know that this works, right? This is one way that we can diagnose ADHD, and in fact, it's the way that we do it right now. But there are some important shortfalls here. The first is distinguishing ADHD from other disorders. Attention deficits are part of a wide range of disorders, from depression and anxiety to ADHD, of course, but also to things that we think of in the neurologic sphere, like Alzheimer's disease, or a TBI, or a stroke. You can also have attention impairments. The other problem here is that ADHD diagnostic criteria keep shifting over time. The issue here is that as we get more information, of course, we want to update our diagnostic criteria, but it also means that if you got diagnosed yesterday, you might not have the same diagnosis tomorrow. I mean, that's a short time scale, but right, you can think year over year, things keep changing. All of these disorders also present very differently at different ages. So a child with an attention deficit disorder will not look the same as an adult. This is true in ADHD, as well as other disorders with attention impairments. There's also significant racial and gender bias in this kind of diagnostic process. Because we're using subjective questionnaires and subjective measures, we can see very easily how provider opinions or teacher opinions might go into the mix here. People might have heard a lot about girls, for instance, being underdiagnosed with ADHD in the past. This is luckily changing, and people are getting the treatment that they need. But there's still significant concerns here. And then finally, this whole process that I went through is all specialized to ADHD diagnosis. And so when you only specialize to this diagnosis, it means all of this effort and all of this time went into this one disorder. And so you can go down this whole rabbit hole, but you're not going to get out at the end, does someone just have an attention deficit? You're going to get at the disorder itself. So we're asking, what if there was a better way to diagnose attention deficits broadly? And here, we're going to walk you through our building of a VR system that is in an immersive spaceship type environment. This is focused on children for right now, but to see how is someone interacting in kind of a daily environment, even though spaceships are different, and I'll explain why, to see can we capture at those different quantitative measures that might indicate an attention problem. So I'll walk you through our task framework, and then I'll turn it over to Brendan after I explain some of these tasks, who will tell you about the environment that he miraculously made for us. This has been really amazing. So our task framework looks a little bit like this. For 5 minutes, someone gets into our environment, and they explore it. In psychology, we call this habituation. This is someone just getting used to the environment so that when they start the task, nothing's surprising to them, and we can make sure that when they start the task, any effects that we're seeing isn't just because they're in a new environment. And then for 10 minutes, we have created this task based off of a really outstanding paper recently published that created this executive performance and everyday living task. This was a VR-based paper that came out where the inventors and the researchers created an apartment-like environment, and we're asking people to do tasks of daily living in an apartment. Importantly, we switched to spaceship, and we also switched the tasks around a little bit because we wanted to make sure that no matter what socioeconomic status you come from, what background you have, this environment is equally weird to you. I grew up in upstate New York on a horse farm. I had no idea what an apartment was until I was 22. It would be weird to put me in an apartment. I would not know what to do with myself. So this is an important factor, is making sure that we have something that's valid for all different types of people. And then finally, at the end of this, we have some idle time. We're still collecting data in this time, but we want to see what do people do when they're not given a task. So these tasks look a little bit like this. We've designed this right now in 4 different blocks of tasks. The structure's the same for all the different blocks. So first, you get some instructions. You've got 90 seconds to complete a set of tasks, and then there's some rest time. So for the first block, we're asking people, please move your PJs from the bed into the hamper, brush your teeth, put your toys away, choose your outfit from the closet. These are things that most of us do every day. A kid might do it in particular. But again, you're in this different kind of novel environment, and that helps to level the playing field for people. And then for block B, very similar. Here you're taking care of your pet robot. Not everyone has a dog. Again, we tried to equalize these things. In block C, we're making some lunch. So we're not running around the apartment anymore, but we do need to think about put a drink in, a sandwich, a fruit, and because you're a very lucky kid, you get a dessert as well. And then finally, in this block D, we have 2 tasks right now. That's because we're working on building out a second portion of this, this type of system, and that's where we have our transition point. But here, you're getting ready to leave your space apartment situation for the day, and so you got to do one more cleanup thing and put on your spacesuit. So now I'll turn it over to Brendan, who will talk through the tasks that he made.
Thanks, Hannah. All right, I'm going to give you a brief fire hose of how I made this entire VR project. So I'm going to give you a walkthrough of how I made this environment and ultimately created the VR experience that happens in it. So in order to create the environment, I started off with this program called Blender. It's an open source free 3D modeling program. Shout out to the Blender users out there. So Hannah gave me a PowerPoint, which is a floor diagram of what she wanted, and I just basically built from the ground up, building the floor, the walls, the windows, the doors, the ceiling, et cetera. Now it's time to fill this thing up with some assets, right? So if we go to this website, there's a cool website called Sketchfab, and has like a ton of free 3D models that you can download. So I just threw a lot of those models in there and get the vibe of a cool space apartment, right? So the next thing we wanted to do is make this thing game ready, right? If we bring it over into a VR project, you're gonna have problems. Look at that bed. Look at how much geometry is in there. Thanks, Blake, for helping me realize this, that most of these models have so much geometry that if you were to throw this in a VR experience, the frame rate would be low. And one of the tasks that was not included is throwing up. So that's something you don't want to have in the VR experience. So we went through the process of decimating all of these things and basically getting it exported into an FBX file in order to bring it over to Unity, where we would have the actual VR experience. So I don't want to have to recreate the VR wheel. I had like about a month to make this thing happen. So let's start with a template where, teleportation, button interactions, grabbing objects, all of those things are already done, right? So now I can go ahead and bring that model in, the space environment, and look what we have, a basic model. What happened to all the lighting and the materials? Well, we found out, thanks Ben, we found out that everything broke in the process of transferring over from Blender to Unity. They don't work with each other. I guess if you have different 3D programs, there's no universal way of transferring things over. So I had to manually go through every single object, changing the materials and adding the lighting, spending days trying to troubleshoot how that works. And basically, we get something that looks nice. So we have this VR environment. Let's go ahead and make the experience, right? So I want to talk to you about how I implemented AI in the workflow of this. So Hannah, you said that throughout the process, there will be instructions that is given, right? So I thought it'd be cool to kind of copy and paste the script to some website like 11 Labs that would generate a nice AI voice that would go along with this. So this is a real-time recording of how it goes and how fast that is. Copy and paste, and here you go.
Attention, attention. We have a mission for you. Please, open up your robot pet's cage. Next, feed your robot. Then get your lunchbox from the counter, and finally give your robot a ball. You have 1 minute and 30 seconds. Ready? Go.
Cool, so now we have a nice British voice that can boss you around in VR right after 4th of July. So you can have that, and what's cool about this is that you can do rapid iteration. I can slightly change the script, download it, and throw it directly in the game, and now you have something like this.
Mission completed. Stand by for your next mission.
So it's all about saving time, and I'm going to talk about another subject that would save me a lot more time, the actual code generation. So I want to stress that I'm not blindly just copying the code and running it. No offense to Blake, that was really cool. But it's the manual process of being able to shorten the amount of time it takes for me to write the code myself. Let me give you an example of what I mean by that. So let's say I want to create a button, and when I push this button, a hologram pops up, right? I know enough about the Unity API after coding for years to know exactly the Unity speak and the algorithm that I need to go through to do that. And I can code that myself. But it's cool if ChatGPT can get me 80% there. It can generate the code very quickly, and I can go through the process of reviewing, make sure I understand it, and then add the 20% of my own pizzazz to get the thing to where I want it to be, right? And then from there, I can implement this and troubleshoot it, and basically go through that process. And what I found through this process, that I can dramatically reduce the amount of time it takes for me to develop. And now, I feel like instead of coding so much, I really feel like a designer now. Like that time in between where I think the idea and I see it implemented is so short now that it feels godlike. So it's really cool. So let me actually talk about the actual features that we were able to implement with all of this in the workflow. So what was very important is that we wanted to be able to track all of the measures or the metrics from the actual user as they're going around doing this. We want to track what they're looking at, what they're grabbing, how they're moving around, because all of this is super important. So if you look over to the left, this is what the user sees in the recording from their point of view. But on the right, we have a JSON recording of what they're looking at, how they're grabbing it, how they're moving around. All of this is being recorded in a cool JSON file, and I can play that back within Unity. I just thought that was cool. I mean, it's already been done before. I just thought it was cool. But you can take this file also and move it outside of the program and do your own analysis. And Hannah will show you a bit of that later. But yeah, I want to also talk about some other features, which I thought was cool. Not only are we tracking the eye with the MetaQuest Pro, but I thought it was cool to be able to use the eye to activate menus within the game. So as you're going around trying to implement this task, I had a situation where I just forgot what task am I doing. So there's this cool menu that I put up here that just literally says task. And if you look at it long enough, it expands and gives you the task list. So I haven't really seen that done a lot. So try it out in a demo. It's pretty cool. Overall, we had a huge amount of tasks that we had to implement, and I need to find a way to shorten that amount in a short amount of time. So what we did was we broke it up into 2 categories. One is to just grab and drop tasks where you just pick something up, put it somewhere else, and the other one was button activated, where you push a button and something happens. And surprisingly, we were able to cover a wide variety of tasks by just shortening it to those 2 type of implementations. So while you're going around doing these tasks, we make sure to distract you as much as possible. We have posters on the walls where you can just stop and look. We see Frozen. We see all the Disney movies. You have holograms where you push a button. Cool holograms will pop up that have no use at all but to just waste your time. We have random animations like screensavers on the wall. We have robot agents that you can throw a ball and it will just chase around. It's pretty cool. We have a robotic arm coming out of the wall. We have spaceships moving around the apartment. If you look outside, you'll see it. Buttons you push and you don't know what they do. Sometimes I just add a random sound in there and it does nothing. And you're like, what's going on? So all of this is to give you this vibe of you're going around trying to execute these tasks. I have it sped up. Of course, it's not going to be this fast. But you're going around trying to execute these tasks while all of these distractions are happening. So Hannah will tell you about the data from one of my recordings of actually testing it out. And I'll pass it back to you.
Thank you. So this was an astonishing amount of development that happened in about a 4-week time frame. I was really like, Brandon, I hear that you have AI on your side these days. Like, how fast can we make this happen? And he was like, I got you. But we haven't gotten to a place yet where we've been piloting this study with people with attention deficits versus not. So like I said, we're just going to show some of Brandon's data here. If you notice anything funky, go talk to Brandon. So one thing that we can track over time is things like where someone is in the scene. And we have a hypothesis that maybe if you are less efficient in moving throughout the scene, maybe in different blocks you're showing more movement, kind of as if you put every little dot there and put a little piece of string in between and then measured the string later. So in the dot plot on the left-hand side of the screen, the darker colors indicate where the location was at the beginning of the task, and then the yellow is where you are at the end. And so you're moving through X, Y, and Z. Really amazing that we're able to get that data out and then get a summary statistic of before you started a block, during the block of tasks, before, after, et cetera, how many gain units you're traversing in there. Again, the hypothesis being, if you have problems executing this task, maybe it takes you a little bit longer, but maybe also you're just less efficient in your route planning. Brandon also mentioned that we have eye tracking implemented in this. This is particularly interesting in the context of attention deficits because what our eyes can capture across the scene, sometimes we kind of flit across the scene, but maybe you won't all the way walk over there. And so we can track the left eye gaze location over time and then similarly look at what's the distance that your eye is traveling with a hypothesis here of maybe if you are looking all over the place constantly, once again, it's a less efficient route for your eyes to be taking, and then we see a bigger distance. We can also combine some of the data together. So we have information about the location of objects in the scene. This is just one example from a task where someone is supposed to be brushing their teeth to get ready for the day. And so the round dots are showing where the eyes are looking, and then the plus signs are showing kind of the trajectory where the toothbrush location is. And so we can see that at the same time, aka the same colors, where were you looking versus where are the objects? And this one was really interesting to us, specifically in 3D, but the GIF was not GIFing. You can see that the trajectory of that toy rocket that you're supposed to be putting in the bin, you can see it change over time. Then you can also see maybe you're looking at it over time, or maybe you're moving on and doing something else. We're not exactly sure which of these interesting features or different metrics will come out as important when we look at people with attention deficits versus controls, but we know that having this data will be informative. So what's next? We have all of these different measures, like where the objects are in the scene, how they're rotated, how they're moving, how are you engaging with distractors, like looking at them. So we want to put all these different data streams together to get measures like task efficiency and task accuracy. Did you do all those tasks in the right order? How many times did you look at that drop-down menu to remind yourself what the tasks were? And then we also are thinking about adding on some additional data streams, like audio recording and video recording of someone actually engaging the tasks. It was really funny. Brandon put the headset on me yesterday, and I was like crouched down like this, trying to move around the scene. I don't work in VR. I'm a cognitive scientist. I don't know what I'm doing. And so maybe if we got some data from the outside looking in, we could also have some objective measures of how are people actually engaging with this, and are they understanding the premise of the task, just to validate that people are doing okay in VR. Again, I sit in the neuroscience group, and so I'm always interested in when can we get some more brain recording in here. And one thing that we're looking to implement in the near future is adding in FNIRS. This is a measure of blood flow in the brain. You strap on a cap. It's a little funky, but it works. And the reason why we want to do this is to correlate these behavioral measures we're getting out of VR with differences in hemodynamic activity, blood flow, in the very front part of the brain, the prefrontal cortex. There's some other evidence from more lab-based experiments that maybe there's some differences in how the brain is being perfused with blood in different areas in ADHD versus controls. We're also interested in piloting this system with both APL volunteers and in children with and without ADHD. This APL volunteers bit is to bug fix, find all the things that we didn't find, make sure that this task makes sense. And then eventually, again, with children with and without ADHD, with the help of Dr. Allison Pritchard at the Kennedy Krieger Institute up in Baltimore, so that we can see, can we detect some meaningful differences between these populations? And then finally, because the overarching aim of this isn't just can we diagnose ADHD better, it's can we spot attention deficits as a broader category better. We want to make sure that we can drag and drop out the tasks, change the environment subtly, change the distractors that are in there to make a version that's suitable for adults with various disorders across all of our different stakeholder landscapes. Everything from things that we think about with warfighters, like TBI and PTSD, to things that we might think about more in the civilian context, like anxiety and depression. So thank you so much. We'd be happy to take your questions. Oh, I love that. That's okay. Don't trip. Take your time.
Hi. So that was a great presentation. I really, really liked it. One thing I am familiar with in ADHD diagnosis is that tests themselves can sometimes be expensive, time-consuming. So one of the things that strikes me as very interesting about this idea is that do you guys think there's any potential to be able to deploy this over the entire United States or further, just virtually without needing to actually be there in the room with the person taking the test? Because from what I'm seeing here, all that data you're collecting can be analyzed and looked at no matter where you are relative to each other. And typically, you go to a control room and you go to something where they have this special computer or this this doctor, and maybe that's not necessary in this case. Do you have any thoughts on that?
Yeah, for sure. So I can answer a little bit from maybe like the public health half of the equation, and then if you want to answer from the technology side. Awesome. So from the public health side, I get nervous anytime anyone is like, we should just universally screen for the thing, because when you look for the thing, you find more of the thing, and you're not always sure if you're finding the right thing. So whether this is something that should really be done universally, I'll always be cautious to say. But what is interesting, what you were just talking about, is the accessibility concerns and making sure that this is something that everybody can use. VR is expensive, that's true. Specialist time is even more expensive, that's also true. And so the hope is here that this is not just something that is more objective, but also something that enables better diagnosis across, yes, ADHD, but more broad disorders too.
Technically, I don't see any reason why, if the headset isn't distributed to the people using it, why it can't be sent across the United States or wherever else.
Okay, great. Thank you.
Thank you.
Are you also tracking engineering diagnostics in a sense? Because I could imagine that if the frame rate drops, that could dramatically affect your eye tracking and other things, and you need to be aware that it dropped.
Yeah, I think that'd be a good thing to track at the moment. Right now, it's just, can we get it done?
Yeah, absolutely.
Definitely, yeah.
We've been very much in a rapid prototyping type of phase, but it's a really important point that you're bringing up. And one of the things that I think we were trying to get at a little bit with the external video feed and external audio monitoring to see maybe someone would say, oh man, it glitched. And then we can make sure that we've captured that. But yeah, the easier way is absolutely we should track what's going on in the engineering world. Thanks.
Hi, this is a pretty specific question, so just wanted to hear what you thought about it. One of the big issues with ADHD medications between the name brand and the generic is that they actually both use the same drug. It's actually the capsule that's the difference. Mm-hmm. And it'd be interesting to understand if this tool could be used to test to see whether, and measure which one's more, if you had two different medications, if it could be used to provide some actual tangible data on which one's more effective.
Yeah, definitely. That's a great point. I don't think that we have the near-term goal of using this for medication, kind of precision medicine aims, but one of the things that we have thought about is, could this be used to track symptom states over time? It loosely gets to what you were just alluding to of, can we see if someone's improving or not? But yes, this would be, the vision of this is, yes, it can help with diagnosis, but also see how someone's doing. Thanks.
Hi. Okay, I saw you say something about right hand and left eye tracking, I believe it is. Is that sort of code for dominant hand, non-dominant eye, or did you pick the left eye and the right hand specifically for another reason?
Did you have a technical reason?
Well, it was literally the right hand and literally the left eye. But that was, I think, it was like the picking of the data, I think, maybe?
Yeah, so right hand, most people are righties. I know at least when I first went into the scene, I used my right hand. We also have left controller data, I believe. I just chose right hand as my first analysis, showing my own bias. And then as far as left eye goes, it was a little bit arbitrary, right? So you could use right, you could use left. Left is just what we picked up on. All right, we fixed it. Thanks.
All right, thanks you, Brandon and Hannah.